quite a few definitions in this vodcast, so every once in a while you may need to pause me so that you can write down the definitions, but you also want to get the contextual examples down in your notes as well, because you're going to be expected to apply these sampling methods to a different contextual situation on the homework, on the CA, on the test, on the final exam, so you want something that you can go back and look at later on. So first up, we have two definitions: population, which is an entire group that we want information about, and then sample, which is a part of the population. It's the part that we actually examine in order to gather information. And I thought in order to investigate this that we could investigate a question that's probably of interest to you. You guys took a test on Monday and Tuesday. And so something that you might want to investigate is, what is the mean grade on the intro stats regression test? So to investigate that, we need to think about our population, our sample. We need to think about something called our parameter. So just to start out, what is our population? Well, our population is 80 intro stats students. Just to think about it a little bit further, Mrs. Peterson has 3 classes. She has a first period, a 7th period, and an 8th period. And Mrs. Howe has 2 classes. She has a 2nd period and a 5th period. So 80 students, 2 teachers, 5 class periods. And we want to think about how we're going to investigate this. Just as a side note, the mean grade is quantitative. And the reason that it's quantitative is because what we have is a list of numbers that finding an average makes sense. Off the screen there. Quantitative, a list of numbers that finding an average makes sense, as opposed to something that is categorical. And that's usually where we group data into categories. And one example that I always use is I always say, if we're interested in favorite colors, then when we ask people what their favorite color is, we'll put them into the category of blue or green or pink or orange or whatever it happens to be. While in this scenario, we're not putting people into categories. We're asking, what grade did you earn? And so we're going to get a number, and it makes sense to find the mean later on. Okay, so 80 stat students, 2 teachers, 5 classes. What's the mean grade, and how are we going to figure this out? One thing that we could do is we could take a census, and a census is an attempt to contact every individual in the population. And so this is where we go to every single class and we ask every single student, what grade did you earn? And when we ask them what grade they earned, we collect all those grades together. There's 80 of them. We add them together. We find the mean. If we did something like that, what we would have is we would have a parameter of the population. So the parameter is what we are measuring. And what we would have in this case is we would have something, usually we use the notation of mu equals. So mu equals whatever the mean grade is, and I don't know what the mean grade is. I haven't collected it yet. But if we have the entire population, what happens is we have the parameter of the population, and we usually use a mu to denote that. I suggest that we don't do a census. It's going to take us a long time to go ask 80 people. People might be absent. It's just going to be difficult for us to collect all that information. And so it may be a little bit better for us if we actually do a sample, which is where we get a small part of the population. So one thing that we could do is we could do a convenience sample. A convenience sample is when the sample consists of people who are easy for us to ask. So who would be easy for us to ask? Well, I feel really comfortable around my friends, so perhaps I go and ask, 10 of my friends. So 10 of my friends and me, and then I have a sample of 11. I know that there are 80 stat students, but I have a sample of 11, which is much better than my one test score. And when I get that mean, what I have something called a statistic, which, remember, the name of your class is statistics, so you're doing a lot with a statistic, which is the measurement, the same measurement from this parameter right here. So remember, the parameter was of the entire population. The statistic is a measurement on the sample. And when we do a statistic, the notation that we use for a statistic is this notation, which is usually x with a bar on top of it, x bar. So what we hope that our statistic, which is about the sample, describes the parameter, which is about the population. They may not be exactly the same, but we hope that they're close. The problem is that we're never going to know because we don't know the population, or we didn't ask the population. We only know our sample, so we only know the statistic. You should be thinking about some problems about asking just your friends. You and your friends may have some characteristic that the population doesn't have. Perhaps you guys are especially studious and math comes easy to you, and so you did really well on the test. But maybe that's not the case for everybody. So maybe when we find this X bar for you and your friends, it's actually higher than mu. So the measurement on the sample is higher than the population, excuse me, because you guys are especially studious. All right, so what's some other way that we could take a sample? Well, we could ask for a voluntary sample. So we could go someplace and say, hey, I want to know what the mean grade on the regression test was. If you want to tell me, come tell me. And I can think of a couple of different ways that I could do that. One thing that you guys are very fond of is making an announcement at assembly. You could say, hey, meet me outside of Founders if you're interested in telling me what your grade was on the regression test. You could solicit volunteers from Facebook or whatever social media you young kids are using right now, for your friends to tell you what grade they made on the regression test. I think one of the issues with this would be that you guys are more than happy to volunteer information when you've done really well, but not so much when you don't do well. And that makes sense, you know, when you don't do so well, then you don't really want everybody to know it. So I think one of the issues with a voluntary sample is that you could have an inflated grade on a voluntary sample because people that did well would be more likely to volunteer their grade on the test. Okay, so some good sampling. What we want is probability samples, and so we're going to look at a few probability samples. The first one is a simple random sample, and that's where every set of n individuals has an equal chance of being selected for the sample. So what we do when we do this is usually, not all the time, but usually, we put our population in order. Alphabetical is a great way to do it. So the first person I'm going to bet would be Suhaib. And, sorry about that, Suhaib. Okay, would be Suhaib. He would be the first one alphabetically, and we would assign him the number 1. And then we would see who the second person was alphabetically, and we would assign them number 2. And then we would see what the third person alphabetically was, and we would assign them number 3. And we go all the way down to the 80th person, which I think would probably be Hannah. And then after that, what we would do is we would say, hey, what do we want our sample size to be? Well, maybe we want a sample size, we usually use n for sample size, of 10. We want to have 10 in our sample size. So we would get out our handy dandy calculator, and we would go over here to this math button on the left-hand side, over to the probability menu item, and the fifth one down is something called random integer. Random integer takes in three numbers: a low, a high, and how many we want. The low number that we assigned was 1. The high number that we assigned was 80. And we said that we wanted 10 random numbers, so maybe we make this 10. I have a tendency to do just a little more than I want because it's possible that I could get repeats. Maybe Hannah shows up twice, and I don't really want to ask her twice what her test was. So the second time she shows up, I throw her number out and I get a new number. So what I've done right now is I've said from 1 to 80, generate 15 random integers for me. Okay, and so there are my random integers. So the second person on the list is going to be in our sample. We're going to go ask them, the 34th person, the 25th person, the 78th person, and so on like that. I'm not sure I see anything that is repeated here, but maybe there is a repeat later on. But like I said, if this 34 came up twice, the second time I would just throw it out and get a new random number, and that's why I generated a little bit more than what I wanted. And so then I would go to those 10 people, I would ask them their grade, and then I'd find the mean of those 10 people, and I would have a statistic, right? It would be an X bar. And what I would hope is that X bar would be similar to mu. Remember, X bar is the sample and mu is the population. We didn't ask the population, we only asked the sample. So we have an X bar. And we hope that it is similar to mu. It may or may not be, but we're not going to know. If we took a probability sample, though, it should be close. Okay. The next type is called a cluster sample. And so a cluster is where you divide the population into groups or clusters. And then you randomly choose a cluster, and every single person in that cluster is in your sample. I think great clusters for us would be to do this by period. So we could label number 1 first period. And then we could label number 2 second period, and then 3 would be 5th period, and then 4 would be 7th period, and then 5 would be 8th period. All right, so there's our clusters. Then we randomly choose a cluster or 2 clusters. I don't know, it depends on how many you want in your sample. So we go back to probability, we go back to random integer. Oops, what did I do? Okay, so random integer, I think I'm on a wrong line. Okay, so math, probability, random integer. The low that we assigned was a 1, the high that we assigned was a 5, and I think this time I'll just pick one cluster. So we're going to get one random integer from 1 to 5, and we got a 1. So that means that we go to first period, and everybody in first period gets to be in our sample, and we don't talk with anybody else. So our X bar from our sample represents everybody that we ask in first period. And that may or may not be a problem. That's Miss Peterson's class. Maybe Mrs. Howe graded slightly differently, although hopefully not, because they discussed how to grade the test, so they should be as consistent as possible. I think one of my worries would be that first period is early in the morning, as opposed to an 8th period that's in the afternoon or a 5th period that's in the middle of the day. But, you know, we did it randomly, and we now have our sample, and we have an estimate. We just don't know if it's similar to mu or not. Okay, so another way that we could do this is a stratified sample, and this is where we group the population, but we group on a characteristic that we think may affect the outcome. And I don't know, what do you think would affect the outcome here? Do you think that the teacher grading may affect the outcome? Do you think that morning versus afternoon may affect the outcome? It kind of depends on you as to what you think would affect the outcome. I beginning of it was me, what I would do is I would get a list of Miss Peterson's students, and I would label those as 1 through, however many students she has. I think she has, let's say that she has 43 students. That could be totally wrong though. And then I would get a list of Mrs. Howe's students, and I would label them 1 through, this one should be 37, is that right? So that it adds up to 80. And then what I would do for a stratified sample, remember with a cluster, I randomly chose a cluster and talked with everybody in that cluster. And a stratified, I want some from each strata. So I want some from Miss Peterson and some from Miss Howe, and so maybe I randomly choose 5 numbers from Miss Peterson's students and 5 numbers from Miss Howe's students to make a sample of 10. Miss Peterson does have slightly more students, so maybe I find out proportionally, 43 out of 80 is whatever percentage, and 37 out of 80 is whatever percentage. And maybe it ends up that I take 6 out of Miss Peterson's classes and 4 out of Mrs. Howe's classes, and that becomes my sample, and that becomes my X bar. Okay, so last type that we have is something called a systematic sample. And a systematic sample is when we randomly choose a starting place, and then we talk to every nth person after that. So what I might do is I might pick a random number between 1 and 5, and I get a 4. And then I'm going to pick a second random number, possibly between 1 and 5, maybe between 1 and 10, and I get a 5. Okay, so the first random number that I got was a 4, so that means I start with the 4th person. So maybe I catch the people walking out of first period, and I talk to the 4th person walking out the door, and then every 5th person after that. So I'm going to have to be outside the door, 1st period, 2nd period, 5th period, 7th period, and 8th period, because I'm going to have to catch that 4th person walking out the door, 1st period, and then I've got to do every 5th person after that. I think that would be the easiest way to do it, because I've got to get it from my population. Okay, and the very last thing is something called a multi-stage sample, and that's where I employ multiple sampling methods, or possibly the same one more than once. For example, when we did our cluster sample back here, and we said that we were going to go into first period, well, first period is, laid out in a group, right? So maybe I label first period even more. Maybe I say that this is a cluster, and maybe I say that this is a cluster over here, and maybe I say this is a cluster, and maybe I say this is a cluster. So 1, 2, 3, 4. And so I randomly choose a number between 1 and 4, and then I go in and interview everybody in that cluster. So I did a cluster within a cluster. My first cluster was saying I'm going to do first period, and then my second cluster told me what area of the room I was going to investigate. All right, that's it. Good luck.